In the last couple of lectures, you learned about inheritance and composition. In this lecture, I'm going to talk about problems with inheritance, and then I'll explain the advantages of composition over inheritance. Before we start, let's review what you learned in the last couple of lectures. So you saw that with inheritance, we can get code reuse. I showed you an example of a presentation object where we wrote some common code that was inherited by text, table, and image classes. You also saw an example of code reuse using composition. So we had a logger class where we defined the logging capability, and then we used that class in DB Migrator and installer. Now the problem with inheritance is that it can easily be abused by amateur designers and developers, which can easily lead to large hierarchy of classes. Such hierarchies are fragile. If you change a class on top of the hierarchy, all the classes inherited from that will be affected. And this is because of the tight coupling that comes with inheritance. Let me show you an example so you can see all these problems in practice. Imagine we are designing a game and we would like to introduce the concept of a person and a dog. Both person and dog classes can have attributes such as age, and they can have methods such as eat and sleep. So with inheritance, we can create an animal class and then derive person and dog from the animal. Now let's say we need to give the person and dog the capability to walk. So we need to go in our animal class and change that class by adding a new method called walk. The problem at this stage is because both person and dog derive from animal, they will be affected as a result of this change. Sometimes when we change a class, the dependent class may have to be changed, or at least it has to be recompiled and redeployed. Okay, now to make the matter worse, let's imagine we would like to introduce the concept of goldfish. So we add a new class called goldfish that derives from animal. But there is a problem here. The problem is that the goldfish cannot walk. So our inheritance hierarchy needs to be modified, which means we have to take that walk method outside the animal class and probably create another subclass called mammal, where it has the capability to walk, and then we can derive person and dog from mammal. So as you see, the hierarchy is getting changed again. So that's the reason inheritance can easily be abused by amateur designers and developers, and it results in large hierarchies. And such hierarchies are fragile because of the tight coupling between classes. Now I want to show you something. I want to show you that any inheritance relationship can be translated to a composition, and that can result in great flexibility. So let's review the same problem and see how we can model these classes using composition. So this time, instead of person and dog deriving from animal, they have an animal. Now the first thing that may confuse you here is that a person conceptually is an animal. At least that's how we define the concept of person in the English language. Well, that's exactly where the problem happens with inheritance. Most amateur designers try to model software using real world. Just because in the real world a person is an animal doesn't mean we should always use the inheritance or is a relationship between these two classes. We as software engineers need to think differently. We need to design our classes such that a change in a class is isolated and has minimal impact on other classes in the system. And doing so requires a different way of thinking, not the way that we think in the real world. We basically need to think in objects. Okay, back to our example. Let's say we forgot to give the person and dog the ability to walk. Now, how can we model that using composition? Well, first we introduce a new class called walkable, which has a method called walk. This walkable class describes the behavior of walking for any kind of animal. Next, we create a composition between person and walkable. Same for the dog. Now, what happens here is that a person has an animal and it also has a walkable. So it has the capabilities defined in both animal and walkable. Now let's say we would like to add a goldfish. So we create a new class called goldfish that is composed of animal. Goldfish cannot walk, so we are not going to create an association or relationship between goldfish and walkable. Note that in the example with inheritance, adding the goldfish class broke the hierarchy. But here we simply added a new goldfish and created a composition between goldfish and animal. Person is not modified, dog is not modified, animal is not modified, neither is walkable. Now let's say we would like to give our goldfish the ability to swim. So we can create a new class called swimmable, which has a method called swim. And then we create a composition association between goldfish and swimmable. Again, none of the classes in the system have been modified. Tomorrow we can introduce a new class called duck. A duck is an animal, it can walk and it can swim. So again, we can create a composition between duck, animal, walkable and swimmable without any impact on person, dog and goldfish. So as you see, with composition, we encapsulate some common functionality and then we compose them together, we tie them together to create new classes. Using this technique, we can create new classes with new capabilities of the existing classes. We compose them together. And this has minimal or zero impact on other classes. So with composition, we get great flexibility, but we also get loose coupling. How? Let's take a look at both the composition and inheritance relationships in terms of coupling. So here in this picture, we have both an example of inheritance and composition. In this example, coupling between person and animal, irrespective of the kind of relationship, is equal. So whether we use inheritance or composition, if animal is changed, person may have to be changed or at least needs to be recompiled and redeployed. But there is a catch here. With composition, we get an extra benefit, which is not possible with inheritance. And that is, we can replace the animal class on the right side with an interface. Interfaces are extremely powerful, and that's the reason I've dedicated a full section on them. For this lecture, don't worry about it. All I want you to take away from this lecture is that we have two types of relationships between classes. One is inheritance, which is also referred to as is-aid relationship, and another one is composition, which is referred to as has-aid relationship. Both inheritance and composition have pros and cons. Inheritance provides code reuse, and it's easier to understand than composition in certain examples. For instance, in the example you saw earlier, we usually think a person is an animal. So modeling that using composition like person has an animal is a little bit harder to understand. But the bad thing about inheritance is that it creates tight coupling. It can easily be abused and result in large hierarchies, which are fragile. A simple change can propagate to many parts of the application, and that change can be very costly. Composition, on the other side, provides great flexibility and loose coupling, but it's a little bit harder to understand in some cases. Now, I'm not telling you that inheritance is necessarily a bad thing. In fact, both inheritance and composition are great techniques, but you need to use them appropriately. What I want you to take from this lecture is, just because in the real world we think of a lot of relationships as inheritance or is a relationship, doesn't mean we need to model them the same way in software. Because again, doing so can easily result in large hierarchies with many levels of inheritance. That's it for this lecture. I hope you enjoyed it and thank you for watching.